unit today, and this unit is on force and motion. So we've been talking over the last few weeks and months about motion of objects, and mainly around velocity, acceleration, and so forth. Well, today we're going to expand that concept to include what causes objects to accelerate, and those are forces. Okay, so I'm going to jump ahead a little bit and talk about something that isn't really on this sheet, on this warm-up. This is a warm-up. I'm going to use something that isn't on here to try to get a little bit ahead of things here. And what I want to kind of say is pretty simple, and that's that to kind of define what a force is, you know, a force causes an object to accelerate. Okay, so basically, if a force is applied to an object and that object has a certain mass, okay, it can cause that object to accelerate. And we know that acceleration is a change in the velocity. Okay, it's a change in the velocity. So force causes an object to accelerate, and we know acceleration is a change in velocity. Okay, so basically what a force does is it causes, I want to put these two things together, a force causes an object to change its velocity, either to speed up, slow down, or change direction. Okay, so with that said, let's talk about this thing where there's a group of ideas here from A to L, and this talks about, well, how can we define motion and forces and relate those two things? So these are some possible ideas that you could come up with that you could say that help define what forces and how they relate to motion. Okay, so let's talk about them. So let's talk about number one right off the bat. If there's motion, then a force is acting. Well, if you think about that in the concept of, or in the context of what I just told you, that forces cause an object to accelerate, and acceleration is a change in velocity, well, there could be motion. You know, there could be motion. There could be something moving at a certain velocity, but that doesn't mean a force is necessarily acting, because the object could be in motion, but it's not accelerating. Okay? Number B is kind of a similar statement. It says if there's no motion, so A wouldn't really be true, okay? Number B is sort of a similar statement. It says, well, if there is no motion, then there is no force acting. Well, that's not really true, right? I mean, if you think about it. Like, for example, I'll give a really good example. There is a book sitting on a table, and that book is not moving, okay? But there is a force or forces acting on that book. And one of the forces is gravity. And gravity is holding the book on the table. Gravity is keeping the book stationary on the table. So in the case of number B, yeah, there could be a force acting like gravity, but that force, but the book isn't moving. In fact, the gravity force is actually keeping the book kind of anchored to the table. So B doesn't really have to be true. Okay, so the next one, C, well, there cannot be a force without motion. Well, sure. Same example as B. You know, there's a book sitting on a table. It's just stationary on the table. It's at the rest. There's a gravitational force acting on that book, but that book is not moving. Okay, so there can be a force. There can be a force without motion. Okay. Number D. Okay, objects can continue moving in a straight line without applying a force. Well, think about the two statements I made a minute ago. Force causes an object to accelerate. An acceleration is a change in velocity. Okay, so if you look at D, objects continue moving in a straight line. Well, if something's moving, continuing to move in a straight line, at the same velocity, okay, without applying a force, then that object is going to accelerate. Well, yeah, is that an object moving in a straight line at a constant velocity is not accelerating. Okay? So if it's not accelerating, then there is not a force. Okay? So number D is true. You know, objects can continue moving the way they are moving, you know, without applying a force. Forces change the motion of objects. Okay? Forces change the motion of objects. Okay? When an object is moving, there's always a force in the direction of its motion. Well, there could be, but there doesn't have to be. Okay? Because if an object is moving at a constant velocity without acceleration, then there isn't, and it's moving in the same direction, it's not changing direction, then there isn't a force acting on that object. Okay? Okay. Number F, moving objects stop when their force is used up. Well, I can see why people would say that might be true. And on the Earth, obviously, when we have forces like air resistance, which is a drag force, or friction, which is also a drag force, that, you know, there's this idea that you apply a force to an object and the object moves, but eventually the object stops because the energy in the force gets used up in some way, right? But in Newtonian physics, that's not really true. So basically, that we don't use up a force necessarily. Okay. So, okay. Okay. So that's not really true. Okay. Forces act on objects at rest. Well, they sure do, don't they? You know, they sure do. Okay. So the book on the table. Okay. Okay. The book on the table. In that case, you know, you've got, you know, I'll just call this the book on the table example, right? Forces do act on objects at rest. For example, the book on the table is acted on by a gravitational force. And that gravitational force holds the book on the table. The table is at rest, but there is a force acting on it. Okay? The stronger the force, the faster the object moves. Well, that certainly could be true, right? Not necessarily true, but it certainly could be true. It isn't always true. Okay? Sometimes the stronger the force, it causes an object to slow down its movement. Basically, forces, you know, forces cause acceleration. They cause a change in the object's motion. Okay? So the stronger the force, the faster an object moves. Well, maybe, but they're basically, the stronger the force, the more the acceleration potential. Okay? Rather than the faster that it moves. Okay? Number I, constant speed results from constant force. Well, if you think about it, if forces cause objects to accelerate, if an object is moving at a constant speed, okay, then it has no acceleration. And if it has no acceleration, then it doesn't have a change in velocity and it's not accelerating, and therefore there's really not a force acting on it. Okay, so an object at constant speed is not accelerating. So the answer to that is probably no, huh? Okay, Jay, a force is necessary in order to change the direction of motion. Yeah, for sure, because acceleration is a change in the velocity. And there are three ways the velocity or something can accelerate, right? One is speed up. One is slow down. And one is change direction. Okay? So you look at that, a force is necessary to change the direction of motion? You bet. because without a force, the object would continue moving or continue at rest until an outside force is exerted on it. Okay, last two, K, forces make things go. Losing energy makes them stop. Well, forces can make things stop too, right? So forces don't always cause things to go. Sometimes they cause them to stop. And one thing I think you need to be careful about is don't mix up energy with forces. Okay, forces and energy aren't the same thing. Okay, so that's not really true. Okay, the last one, L, forces can be transferred from one object to another during motion. Well, in a way I could see why that happens, but really the way I think to think about that is energy can be transferred. Really from the standpoint of forces, let's think about forces as if, they basically cause an object to accelerate and leave it at that. Okay, so I would say on L, let's not carry that too far. Okay, so the last, explain your thinking, summarize your ideas. Okay, so just to make a kind of key point, if you look at all these things that we've mentioned here, I'll try to summarize them. I summarized a bit of it up here with these statements. A force causes an object to accelerate. An acceleration is a change in velocity, and an acceleration is speeding up, slowing down, or changing direction. Okay, if we want to carry that, so we can have forces acting on an object, and if those forces are balanced, we can have objects acting on an object, like say a book on a table. There are two forces acting on a book on a table. One is the gravity force downward, and the other one is the table exerting an equal and opposite force on the book, holding the book up. Okay, so if forces are balanced, an object can be at rest. Okay, an object can be at rest, or it can be moving at a constant speed. If it's moving at a constant speed, it's not accelerating. Okay, in order to get something to accelerate, forces cause an object to accelerate, we need to have unbalanced forces. Okay, so if we have an unbalanced force, in other words, there's more force acting in one direction than other directions, okay, unbalanced force, well, that is going to cause acceleration. Okay, that's going to cause acceleration. Okay, so let's move on, and we'll come back to some of this in just a second.